Hello, and welcome to 5 Minute Math. Today, for our number talk, we are looking at these two mixed numbers and trying to approximate if the difference is going to be less than 1 or greater than 1. So let's take a look at the whole numbers in these mixed numbers, and hopefully we immediately notice that if we just wanted to look at the whole numbers, that's just 4 minus 3, so that's going to equal 1, which means that lands right there between the less than 1 or the greater than 1. So the big key is what's going on with these fractions, right? So we need to compare the 6/13ths and the 6/16ths. And if the 6/13ths happens to be bigger and that happens to be smaller, well, when you take a smaller fraction from a bigger fraction, you can have a little bit left over. You're going to end up with a greater than 1. But if it happens to be the opposite, right? If 6/13ths is smaller, and you take a bigger fraction away from that, well, it's going to end up being less than 1 because you'd end up having to regroup that 4 to make this an improper fraction in order to make it work, so that'd be less than 1. So let's just figure out which one happens to be bigger, 6/13ths or 6/16ths. So one way for us to think about that is to just think about what do we know about fractions when they have the same numerator, right? So I've got 6/13ths and I've got 6/16ths. And I can compare these without doing any type of cross multiplication or even finding the same denominator because they have the exact same numerator. Let me show you what I'm talking about. So let's say I've got some fractions here, and I'm going to say I've got 2/4. All right, I'm going to use 2. Well, let's go ahead and do 3 since that's going to be a little bit more. Watch this. I've got 3/4, and watch what happens. If I take the same size square, but I'm going to break them into 1, 2, 3. I'm going to break them into eighths. Take a look at that. Look how much less is actually shaded in because my denominator got that much bigger. And imagine if I were to somehow find a way to do 16ths, right? Let's see if we can do 16ths here. So this is eighths. In order to do 16ths, I've got to cut each of these little triangles in half, right? So assuming those are all the same size, watch. I mean, that's tiny. That's not even a full fourth. So what we know about fractions is that you can compare them if they have the same numerator because the smaller the denominator, right, 4 pieces, the larger the pieces. Because you're going to take a square and you're only going to break it up into 4 pieces. But the larger the denominator, the smaller the pieces. Think about taking that same square, instead of breaking it up into 4 pieces, you broke it up into 16 pieces. Those pieces are going to be tiny, tiny, tiny. So, how does that help us? Well, take a look. Let's imagine we have a square, and we're going to break it up into 13 pieces. And we have a square, we're going to break it up into 16 pieces. Well, based on what we just learned, these 13 pieces are going to be a little bit larger than the 16 pieces because that's less pieces that I have to break that square into. So if I have 6 larger pieces, that's going to be a little bit larger than 6 smaller pieces. So just comparing these two fractions, 6/13ths is going to be a little bit larger than 6/16ths because each of these pieces are going to be a little bit bigger. So that means I've got the bigger fraction, and then I'm going to take away from that the smaller fraction, which means I'm going to have a little bit left over. So all of that lets me know it's going to be a little bit greater than 1.